Assalamu alaikum wa rahmatullahi wa barakatuhu. My name is Muhammad Muhammad, and today we're going to be talking about Chapter 1, Lesson 3, Data Collection and Experimental Design. So, Section 1.3 Objectives. So, we're going to learn how to design a statistical study on how to distinguish between an observational study and an experiment. And then we're going to learn how to collect data by using a survey or a simulation, and on how we're going to design an experiment, and on how to create a sample using random sampling, simple random sampling, stratified sampling, cluster sampling, and systematic sampling, and how to identify a biased sample. So first we have to design a statistical study. So we have to identify the variables of the interest, the focus we're trying to get, and the population of the study, who we're trying to reach out for, and then develop a detailed plan for collecting data. So we have to make sure we got a plan, so we're not just writing random numbers, we have to know what we're writing. And then if you use a sample, make sure the sample is a representative of the population. And then we have to collect the data, and then describe the data using descriptive statistics techniques, which we will learn later, and then interpret the data and make decisions about the population using inferential statistics, and then identify any possible errors that could have happened. So for data collection, there are observational study and experiments. So first, observational study is a researcher observes and measures characteristics of an interest of a part of a population. An example of that would be like researchers measured the amount of time people spent doing various activities such as paid work, childcare, and socializing. And then the other type of data collection is experiment, where a treatment is applied to a part of a population called a treatment group, and responses are observed. Another part of the population may be used as a control group in which no treatment is applied. The subjects in both groups are called experimental units. In many cases, subjects in the control group are given a placebo, which is a harmless fake treatment that is made to look like the real treatment. And an example of an experiment would be an experiment was performed in which overweight subjects were given the artificial sweetener sucralose to drink while a control group drank water. After performing a glucose test, researchers concluded that sucralose affects the glycemic and insulin responses in overweight people who do not normally consume artificial sweeteners. And then an example of observational study or an experiment. So we're going to figure out if it's either an observational study or an experiment. So the first one is researchers study the effect of vitamin D3 supplementation among patients with an antibody deficiency or frequent respiratory tract infections. 70 patients received 4,000 IU of vitamin D3 daily for a year. Another group of 70 patients received a placebo daily for 1 year. And then since the study applies like a treatment, which is vitamin D3, giving it to a group of people, the study is an experiment, because you're giving something to a population, and then you're testing them, and then doing all of that. And our second example, where is researchers conduct a study to determine how confident Americans are in the economy. Researchers called 3,040 U.S. adults and asked them to rate current U.S. economic conditions and whether the economy is getting better or worse. Since the study does not really try to influence the responses or try to get like a numeric, kind of like a value, like an experiment would get, as we saw earlier, the study is just an observational study. And another type of data collection is simulation, where we use mathematical or physical models to reproduce the conditions of a situation or process, and it usually uses computers, and it allows you to study situations that are like not realistic, or even more dangerous to create in real life, like maybe seeing the effects of how fast this car can crash into a wall and seeing how safe the person is. Obviously, that's not really safe. So this allows you simulation, and then it saves a lot of time and money since it's a simulation. And then, for example, automobile manufacturers use simulations with dummies to study the effects of crashes on humans. And then, as I said earlier, that's an example. And then data collection, another type is a survey, where an investigation of one or more characteristics of a population. Surveys are carried out on people by asking them questions, commonly done by an interview, internet, phone, or mail. And designing a survey, it is important to word questions so that they do not lead to biased results, which are not representative of a population. So, like, you can ask them whether you like Pringles or Doritos, for example, and then you can go out to people and collect give them the survey, asking them to answer the question, and then they'll answer from their perspective, and then this allows you to conclude which one is more popular. And then also, for instance, a survey is conducted on a sample of female physicians to determine whether the primary reason for their career choice is financial stability. And then in designing the survey, it would be acceptable to make a list of reasons and ask each individual in the sample to select her first choice. For example, like, why did you choose the Pringles, or why did you choose the Doritos? And in experimental design, there are three key elements of a well-designed experiment, which are the control, randomization, and replication. And then confounding variables occurs when an experimenter cannot tell the difference between the effects of different factors on a variable. For instance, a coffee shop owner remodels her shop at the same time a nearby mall has its grand opening. If business at the coffee shop increases, it cannot be determined whether it is because of the remodeling or the new mall, right? So maybe like some outside variable affects your subject, and you can't figure out whether it's because you did something to the subject or whether because the outside variable affected it. And then continuing the confounding variable, the placebo effect occurs when a subject reacts favorably to a placebo when in fact the subject has been given a fake treatment. To help control or minimize the placebo effect, a technique called blinding can be used. And then blinding is basically a technique where the subject does not know he or she is receiving a treatment or a placebo. And then double blind is an experiment neither the subject nor the experimenter knows if the subject is receiving a treatment or a placebo. A example would be like testing drinks, and then the person you're using, you'll put the drinks behind a box, and then they'll drink a little bit of it, so there'll be no bias, and then it'll be completely controlled, and subject will be blinded. So, an experimental design is randomization, a process of randomly assigning subjects to different treatment groups. Completely randomized design, subjects are assigned to different treatment groups through random selection. And then randomized block design divides subjects with similar characteristics into blocks, and then within each block randomly assign subjects to treatment groups. And then we got key elements of experimental design: randomization and randomized block design. An experiment testing the effects of a new weight loss drink may first divide subjects into age categories, then within each age group randomly assign subjects to either the treatment group or control group. And as you can see in this image here, they have all the subjects, and then they show the ages from 30 to 39, 40 to 49, and over 50. And then from there, they separate each age group into two groups: control, where everything is the same, and treatment, where you add the placebo. And then same thing for all the age groups. And then experimental design is matched pairs design. Subjects are paired up according to a similarity. One subject in the pair is randomly selected to receive one treatment, while the other subject receives a different treatment. And then sample size, the number of subjects in a study is very important to experimental design, for sure, because if you only have one person testing one thing and they say one thing, it's not going to be as powerful and as meaningful compared to having 1,000 people doing the same thing, since you will get more results and more possible answers. And then replication is like a repetition of an experiment using a large group of subjects. For instance, to test a vaccine against a strain of influenza, 10,000 people are given the vaccine and another 10,000 people are given a placebo. Because of the sample size, the effectiveness of the vaccine will most likely be observed. And an example of experimental design is a company wants to test the effectiveness of a new gum developed to help people quit smoking, identify a potential problem with a given experimental design, and suggest a way to improve it. So the company identifies 10 adults who are heavy smokers. 5 of those subjects are given the new gum and other 5 subjects are given a placebo. After 2 months, the subjects are evaluated and it is found that the 5 subjects using the new gum have quit smoking. And the solution to this experimental design is that first we have the problem, where the sample size being used is not large enough to validate the results of the experiment. And then the correction would be the experiment must be replicated to improve the validity. So you have to repeat it with more subjects to increase the rates. And then another example would be a company wants to test the effectiveness of the new gum again. So the company identifies 1,000 adults who are heavy smokers. The subjects are divided into blocks according to gender. After 2 months, the female group has a significant number of subjects who have quit smoking. And then the solution to this one is that the problem is that the groups are not similar. The new gum may have a greater effect on women than men, or vice versa. So then the correction would be the subjects can be divided into blocks according to gender, but then within each block they must be randomly assigned to be in the treatment group or the control group. So within like the male and female, one has to be given the placebo and one has to be given the actual gum. And then sampling techniques. A census is a count or measure of an entire population. A sampling is a count or measure of part of a population and is more commonly used in statistical studies. Even with best methods of sampling, a sampling error may occur. A sampling error is the difference between the results of a sample and those of the population. Sampling techniques. Random sample. Every member of the population has an equal chance of being selected, and a simple random sample will be every possible sample of the same size has the same chance of being selected. And then random numbers can be generated by a random number table, a software program, or a calculator. And then assign a number to each member of the population. Members of the population that correspond to these numbers become members of the sample. An example of using a simple random sample would be there are 731 students currently enrolled in statistics at your school. You wish to form a sample of 8 students to answer some survey questions. Select the students who will belong to the simple random sample. And assign numbers 1 to 731 to each student taking statistics. On the table of random numbers, choose a starting place at random. Suppose you start on like the third row, second column. And then, as you can see here, the table 1 random numbers, where it has all the numbers here. And then, as you can see, we go into the third row, second column, 71,966. And then we have to ignore the numbers greater than 731. So over here, for example, we got 71,966. Since that number is greater than 731, we take out the first beginning numbers for 3 numbers and end it with 66. And then, as you can see, they did that with the other numbers. And then the students have assigned numbers 719, 662, 650, 4, 53, 589, 403, and 129 would make up the sample. And then a stratified sample, we divide a population into groups, strata, and select a random sample from each group. To collect stratified sample of the number of the people who live in Westridge County households, you can divide the households into socioeconomic levels and randomly select. So over here we got group 1, group 2, and group 3. We have the low income, middle income, and high income families. And then from those groups, they choose 2 random people. And then we have the cluster sample, where it divides the population into groups, which are called clusters, and then select all the members in one or more, but not all of the clusters. In the Westridge County example, you could divide the households into clusters according to zip codes, then select all the households in one or more, but not all of zip codes. And then a systematic sample is choose a starting value at random, then choose every k member of the population. And in the Westridge County example, you could assign a different number to each household, randomly choosing a starting number, then select every 100th household. So we could choose any number, and then selecting every 100th household, it will make it a random kind of sampling, allowing to more various results. And then a convenience sample is choose only members of the population that are easy to get, often leads to biased studies, which are completely not recommended since it could get influenced answers and answers that may not be relative to a lot of people. So an example of identifying sampling techniques, you are doing a study to determine the opinion of students at your school regarding stem cell research. Identify the sampling technique used. You divide the student population with respect to majors and randomly select and question some students in each major. And the solution to this would be stratified sampling, because the students are divided into strata, which are majors, and a sample is selected from each major. And then we have a second example. You assign each student a number and generate random numbers. You then question each student whose number is randomly selected. So this would be a simple random sample, where each sample of the same size has an equal chance of being selected, and each student has an equal chance of being selected. And then we have a third example. You select students who are in your biology class. So then the solution to this, because the sample is taken from the students that are readily available, this is a convenience sample. So the sample may be biased because biology students may be more familiar with stem cell research than other students and may have stronger opinions. As you can see, convenience samples are not really recommended since it could be biased and can give results that may not be popular. And this concludes lesson 1.3. So to give a quick summary, we will go back over here to data collection, and actually over here, designing a statistical study, where it lists the 6 steps to design a proper statistical study. And then we get the 2 types of data collection: observational study, experiment, and then we get examples of those. And then we have a simulation, and then survey, and then we get example of those, and then confounding variables, and then over here we have the blinding technique, and then we learned about randomization, complete randomized design, randomized block design, and then we got examples of those, and then we got matched pairs design, and we got sample size, replication, and then we got examples of those, of experimental design, and then we got sampling techniques, which were census, sampling, and sampling error, and then we got random sample, simple random sample, and then we got example of those, and then we got stratified sample, and we got cluster samples, and then we got systematic sample, and a convenience sample, and we got example of those. And this concludes lesson 1.3. Assalamu alaikum, jazakallah khairan.